So, all right, taking a look at a question and saying identify the longest, shortest, strongest, and weakest bonds from those highlighted below. So, A is an alkyne. B is a alkene. C is an alkene as well. And then D is just a alkane. Like this. So now they want to say identify the longest, shortest, strongest, and weakest bonds from those highlighted below. So what are the ones they're actually highlighting? So I will point at those. That one. This one. That one. And that one. So all sigma, well, essentially the bond, right? So it's a little different here because this is a triple bond, right? And this is a double bond. This is only a single bond and only a single bond too. So when you look at this, what you need to think about probably here is hybridization states, right? Because different hybridization states have different hybrid orbitals, which are the things we use to form the bonds. Are all the hybrid orbitals the same shape? So we learned about different hybridization states and the hybrid orbitals for them. So for instance, let's just go with this carbon right here. What's the hybrid state of that carbon? It is sp. Always box in the hybrid state, right? And this is also a sp. Now that's the hybridization state. What hybrid orbitals go with sp? So be careful. What kind of bonds does this carbon have? Well, carbon always has 4 bonds. It has 2 pi's and 2 sigmas, right? So the hybrid orbitals, I'm going to zoom in just to emphasize this. So if you're sp hybridized, you have 2 pi bonds, right? So we say 2 pi bonds, 2 sigma bonds. So if you have a pi bond, for every pi bond, you must have a p orbital, right? And so what you have left over, you hybridize, remember? And so you made these short, fat sp orbitals, right? So you can imagine if 2 sp orbitals come together, is that going to be a short bond or a long bond? Short, because right, for a bond to take place, you have to have the orbitals actually have to, right? These orbitals actually have to overlap. So between this carbon-carbon bond, that's going to be a pretty short bond. This triple bond is going to be short. Why? Because this is sp hybridized, this is sp hybridized. To form this first sigma bond, these 2 sp orbitals got to find each other, right? So each of these carbons has these 4 hybrid orbitals, right? Each of these carbons have that. So the shortest bond, I'm going to guess, is probably the triple bond, right? You probably knew that already just because you know something about triple bonds being the, right? Somebody's going to say triple bonds are the strongest bonds. They must be the shortest. But, right, it's a little unfair, right? Triple bond, the reason it's short is because of these sp hybrid orbitals, because they're short, right? Because they're fat, right? Okay, so that makes more sense, right? Because these 2 carbons right here, right? Notice how there's carbon, 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 and carbon. I drew it a little differently, right? This is what hybrid state for that carbon? sp2. It has 1 pi bond. So it has 1 p orbital. So if I zoom in on that guy, do exactly the same kind of thing. This carbon is sp2 hybridized. It has 1 pi bond and 3 sigma bonds. For every pi bond, you must have a p orbital. And then what's left over, they're sp2s. Notice how they're a little longer, right? They're partly, they're 2/3 p versus 50% p. So these are all sp2 hybrid orbitals. So these two carbons that are both sp2 hybridized, the sigma bond here is between two sp2 orbitals, right? So that's going to be a little bit longer than the triple bond. Good.
But not the longest.
But not the longest. Now,
So,
so you probably already, you knew, at least to start hopefully, well, the longest one is probably just going to be a single bond, right?
yeah.
So what's the difference between this sigma bond in C and the sigma bond in D? What's different about those two things?
One has a wait, no.
So what's the hybridization state of this
One
carbon?
has a double bond next to the other.
What's the hybridization state of this carbon?
sp2.
sp2, right? That carbon is sp2 hybridized.
Oh, and the other one.
And this one is sp3 hybridized, right? So what two orbitals are forming this bond? That sigma bond, what two orbitals are forming that? What two? So there's a carbon. So if I call this carbon, let's zoom in. If I call this carbon 1 and carbon 2, there's a sigma bond between those two carbons, right?
That's it.
What orbitals are involved in carbon 1 in that sigma bond? No, back up. This is sp2 hybridized. What kind of hybrid orbitals does an sp2 hybridized carbon have?
3 sp2.
Twos.
1 p.
Right? And what do the sp2 orbitals do in bonding? What kind of bonds do these sp2 orbitals form? Sigma bonds. Okay. What kind of bond is this right here? What hybrid orbitals are involved from carbon 1 in this sigma bond? It has to be sp2, right? If you're sp2 hybridized, what orbitals do you use to make sigma bonds? You use sp2s. So this sigma bond right here is between I would say it's between an sp2 orbital coming from carbon 1, right? This is from carbon 1. And then I'm going to draw it like here, a long skinny guy.
Would that one be sp3?
This is an sp3 orbital coming from carbon 2,
So that's basically
right?
okay.
So how does that relate back to this bond then? Between, if I label this carbon 1 and this carbon 2, what's the hybridization state of carbon 1?
sp3.
How many pi bonds does carbon 1 have?
4. Oh no, 0.
None.
0. So it has to be sp3.
2. Go 3.
Yeah, because it would have a hydrogen.
It has a hydrogen there, right? I don't draw the hydrogens in. Does it have pi bonds? Yes or no? That's what you got to think about. Carbon 2. What's the hybridization state of carbon 2?
sp3.
sp3. It has no pi bonds, but it has 3 bonds to hydrogen. So what two hybrid orbitals are forming this sigma bond?
sp3.
sp3 from 2 and an sp3 from 1.
Yeah.
Exactly.
That's what confused me because we didn't write the hydrogen bond.
So what's it going to look like?
It's gonna have
Is it going to be a long bond or a short bond?
short bond.
Two sp3s coming together. One from 1 and an sp3 from 2. Is that bond longer or shorter than when it was just,
Shorter.
well, is
So
sp
the bond
should be longer.
the bond should be longer, right? See sp2 shorter here? See how it's not as long as sp3?
Oh,
So two sp3s coming together is going to be a longer bond, which would make it weaker or stronger?
Should be
Weaker, right? So the weakest bond
Is D.
is D, is also the longest bond too then, right?